Hey everyone, and welcome back to Tech with Peter. This is the channel where we really get into the nuts and bolts of software performance. And today, have I got a story for you. We are playing detective. We're going to crack a fascinating case of how a single viral benchmark sent a major cloud company on this week-long investigation that ended up uncovering bugs not just in their own system, but deep inside the open source tools that, we all use every single day. It all kicked off with a really surprising result that spread like wildfire. And it led to this whole chain of discoveries that went to some pretty unexpected places. So let's start at the beginning, with the number that got everyone talking. This is it. This is the number that started the whole firestorm. A benchmark dropped from developer Theo Browne, and it showed Cloudflare workers running certain CPU-heavy tasks up to 3.5 times slower than a competitor. And in the performance world, that is a huge, huge deal. And honestly, it was a massive surprise to everybody. Now, here's why that number was so shocking. Both Cloudflare and their competitor in this benchmark, Vercel, they use the exact same JavaScript engine under the hood, Google's V8. For a task that's all about pure CPU crunching, their performance should be basically identical. It's like having two cars with the exact same engine. How could one be so much slower? It just didn't add up. And that was the mystery. So the Cloudflare team, they put on their detective hats. And the first thing they did was look inward. Was the problem coming from inside the house? They fired up their profiling tools, the things that let you see exactly where your code is spending its time, and right away, they started finding clues. So to get this first clue, you gotta understand something they do called isolate routing. It's actually a really clever system. To avoid those painfully slow, cold starts, Cloudflare routes traffic to what they call warm instances that are already up and running. It's a whole system designed to be as fast as possible. But in this very specific case, that clever system totally backfired. Here's exactly what went down. The benchmark was designed to send a whole flood of really heavy requests all at once. The router sees this one warm instance ready to go, and trying to be efficient, it just sends everything there. But that one poor instance got completely overwhelmed, instantly. So every other request just got stuck waiting in a massive line. It created this huge latency, which looked like a slow CPU, but in reality, it was just a request traffic jam. And this is a really crucial takeaway, something Cloudflare pointed out in their blog post. This wasn't a CPU speed problem, it was a scheduling problem. All that time spent waiting in the queue, that's not billable CPU time. So yeah, the benchmark looked bad, but it wouldn't have actually cost developers a dime. And since then, they've already tweaked their routing to make sure this kind of pileup doesn't happen again. But fixing the traffic jam wasn't the end of the story, not even close. As they kept digging, the profiler kept pointing to another problem, something much deeper inside the V8 engine itself. And that was garbage collection. This is such a classic developer story. The problem's roots went all the way back to 2017. An engineer set a very specific memory value for V8's garbage collector. And at the time, that was the right call. It followed all the best practices. But, fast forward to today, and V8's garbage collector is a completely different, much, much smarter beast. That old hard-coded setting was now acting like a handcuff, forcing V8 to clean up memory way too often and just burning precious CPU cycles for no reason. And the fix was beautiful in its simplicity. They just deleted the old setting. That's it. They let V8's modern smart system manage its own memory, and boom, an immediate 25% performance boost in the benchmark. A huge speed up that actually benefited every single person on the platform. Okay, so they fixed their platform. Case closed, right? Nope. One benchmark, the one using Next.js, was still lagging. The investigation was not over. And this is where it gets really interesting because the mystery was actually much bigger than just Cloudflare. It went deep into the open source frameworks themselves. The next suspect on the list was OpenNext. That's the compatibility layer that lets Next.js run on platforms like Cloudflare. And the profiler was practically screaming one thing at them: garbage collection. We're talking anywhere from 10 to 25% of the entire request time was just being spent cleaning up memory. That is a massive red flag. And then they found it. The smoking gun. A single, totally innocent-looking line of code, buried deep inside the framework. getBody.length. I mean, look at it. It doesn't look like much, does it? But let me tell you, this little line was an absolute performance disaster.
So what was it actually doing? It's kind of insane. The getBody function was taking maybe thousands of tiny chunks of data And it was painstakingly stitching them all together into one giant multi-megabyte buffer, all just so the code could ask for its .length. And then what? It immediately threw that giant buffer in the trash. It was a colossal amount of work for literally nothing.
And this kind of wastefulness was everywhere, even in how it was handling streams. The old code was just creating layer after layer of adopters, needlessly copying data back and forth. The fix was to just build a stream directly from the data chunks, which cut out all that extra work. It's a perfect example of how these small API choices can create just massive performance bottlenecks down the line. But they still weren't done. The profiler was pointing to one last hotspot that really stood out, something totally fundamental to how React and Next.js work, parsing JSON data. So the issue was that React uses this special reviver function with json.parse. And in this specific benchmark, that little function was being called over 100,000 times for a single request. To make things worse, a recent change to the JavaScript spec had actually made this exact pattern even slower. So what did Cloudflare do? This is the really cool part. They wrote a patch for the V8 engine itself and contributed it back to the open source project. This sped things up by 33% for the entire V8 ecosystem. That means Node, Dino, Chrome, everyone benefits. So after a crazy week of digging through their own platform, tuning V8, and even patching the open source frameworks we all rely on, what was the result? Did they finally solve the case? I mean, they had addressed every single issue they found, from their own schedulers all the way down to the core V8. This was the moment of truth. And the final results, they really speak for themselves. Performance is now right on par, exactly where you'd expect it to be for two platforms running the same V8 engine. The mystery was solved, case closed. But, like any good detective story, this one has one final fascinating twist. The investigation didn't just figure out why Cloudflare was slower in some cases. It also explained why it had been faster in another. It turns out a different benchmark had shown Cloudflare was 3 times faster at certain math functions. Now, instead of just taking the win and celebrating, they investigated that too. They found a performance bug in Node.js itself, and they submitted the fix, which made their competitor faster. I mean, come on. That is just incredible engineering sportsmanship. So, after this whole incredible deep dive, what can we as developers actually take away from it? What are the big lessons from this whole investigation? Well, first, benchmarks can be really misleading. The initial numbers pointed to a slow CPU, but the real culprit was scheduling. Second, massive performance problems can hide in the most innocent-looking places, like that one little getBody.length call. And finally, and I think this is the most important lesson, performance is a collaborative effort. The fixes made here didn't just help one company. They improved things for the entire web development ecosystem. A rising tide really does lift all boats. And that is a wrap on the case of the slow server. It's just a fantastic story of how one benchmark can trigger a chain reaction of improvements that benefit all of us. If you love deep dives like this, getting into the real guts of how software works, make sure you're subscribed to Tech with Peter. Thanks for watching, and I will see you in the next investigation.